Alright guys, hope everyone's doing well. So, tried to do the lighting a little bit differently today. I tried opening up all the blinds and making it a little darker in here just so you could see the letters a little bit more. The lights on and the blinds closed, I don't know, it was really glary. So anyway, I hope this helps. What we're going to be doing today is we are going to be using everything that we've already brought in. From last chapter, going from grams to moles, from moles to grams, and then like from grams to molecules and back the other way. And we're going to combine all of that stuff into our limiting reagent. So what we're going to do, as we've always done in the past, is first off, balance the chemical equation. So let's start there. I think we're good on this. So all we're going to do to balance this is put a 2 in front of NaCl, and everything is balanced. Yes, I will be coming in and out and in and out. Sorry, get used to it. But anyway, after that, what we've done is we have next found our limiting reagent. So let's take both of our reactants. In this one, we are given 100 grams of NaCl and 125 grams of magnesium oxide MgO. So we're going to have 100 grams of NaCl, and as we've done in the past, we are going to convert this to moles. So we found out that we have 58.44 grams of NaCl in 1 mole of NaCl. And we're going to do the exact same thing for magnesium oxide. We are going to go from grams given to moles. So we have 125 grams given. Put that over 1 as we always do. And our molar mass of MgO is 40.3 grams in 1 mole of MgO. Okay. So what I'm going to do is we have to, as we've done in the past, have each one of these in the same moles of that same compound. So let's do moles of NaCl. We'll start off with doing 100 divided by 58.44, and we get 1.71 moles of NaCl. Now, this bottom one, we are in moles. However, we need it to be in the same moles of the same compound as we have up top. So this is where we're going to use one of those mole ratios in order to convert it. So if I have MgO up top, I want MgO at the bottom on this side to make sure everything cancels out. And then on top will be what we are trying to get to. So in this example, we want it also to be in moles of NaCl. Now, we got to put our numbers in up here and down here. And where we get those from, as we've done, we get them from our balanced chemical equation. So for NaCl, there is a 2 in front of it. So we bring that down there. For MgO, there's nothing in front of it, so we know that to be a 1. So for this, we are going to do 125 times 2, and then divide that number by 40.3, and we get roughly 6.2 moles of NaCl. Okay? So we're going to look at these two numbers and compare them. Here I have 1.71, here I have 6.2. We're just worried about which one is smaller. Obviously, 1.71 is smaller than 6.2, so our limiting is going to be whatever compound was associated with our lower number. So for this lower number, we started with NaCl, so our limiting is NaCl. After that, we're done with all of this. We don't need it anymore, so I'm going to erase all of this. There you go, clean slate. So after this, our next step is to find out what they want in the problem. It's asking for how many molecules of sodium oxide and how many grams of magnesium chloride would be produced. So we are going to use our limiting reactant. So we were given 100 grams of NaCl, and as always, we are going to first convert this to moles. We did this in our last step when we were finding our limiting reagent. Okay. I think we're good here. Now, what compound are we trying to get to? In the first part, it's asking for molecules of sodium oxide. So we want to go from moles of NaCl to moles of Na2O. In order to get moles of NaCl to cancel out, we're going to have that on the bottom. And then on top is what compound we're trying to get to, and they are asking for moles of Na2O. So, how do we get the numbers from here? Again, we're going to go up to our balanced chemical equation. 2 goes down at the bottom. In front of Na2O, there's nothing there, so that's a 1. All right. Now, our last step, yes, I'm coming into the picture. Our last step for this part is we want to get to molecules. So, I have, thus far, canceled out my grams of NaCl, that's gone. I've canceled out my moles of NaCl, that's gone. And now what I want to do is I want to cancel out my moles of Na2O. So moles of Na2O is going to be at the bottom, and then up top is where I'm going to put the molecules. Now if you remember the conversion factors from last chapter, a nice little chart I gave you guys, we are going to have 6.02 times 10 to the 23rd molecules, or formula units. I'm sorry, in this example it would be formula units. Just erase that to make it neater. Okay. In 1 mole. So your last step that you have to do is get your calculator, and we are going to be doing 6.02 times 10 to the 23rd times 100, and we are going to divide this by 58.44 times 2, and overall we are going to get 5.15 times 10 to the 23rd formula units of Na2O. Okay? So that's how you do the first part, where we are going from grams of our limiting reactant all the way to molecules, or formula units, whatever you want to use, of Na2O. All right, so that's your first step. Now, the second part, so this is your answer. We're done with that. I'm going to erase it. So this would be one answer to the first part. It's asking for how many grams of magnesium chloride. Well, what we can do is we can actually just erase this part here and erase this top part here. Everything else we can leave the same because that's just involving our limiting reactant. Now what we're going to do is we are no longer going to Na2O, it's now asking for grams of magnesium chloride. So what compound are we trying to get to? It's going to be moles of MgCl2. There's our mole ratio. What is in front of MgCl2? It's going to be a 1. And then lastly, what we have to do is we are going to go to grams. So we're going to have moles at the bottom. And then up top, we're going to have our molar mass of, I'm going to check it over here, of magnesium chloride, which is roughly 95.2 grams. And then we just have to enter this in your calculator. So the only thing that really changed here was our top part of our mole ratio in order to get to a different compound. And then lastly, instead of going to molecules, we went to grams, so we just changed this conversion factor up. So it's going to be 95.2 times 100 divided by 58.44 times 2, and we get 81.45 grams of MgCl2. All right, so there's your answer for the second part of this, guys. Sorry I've been coming in and out, but hopefully you were able to see everything going on. If you guys have any questions, I'll post this later today. You can bring your questions tomorrow. So have a good day, guys.